Welcome to the Unnamed Reverse Engineering Podcast. Hi, I'm Jen Castillo, and with me
is Alvaro.
Is that guy? Oh, good. You know your name. Thank God.
We never know who does it first.
We never know anything. We really have to do this more often, Alvaro. And with us today, we have Mickey and Jesse, who are going to talk to us about BIOS and UEFI.
I like the
I'm sorry, I have a lot to discuss. I had a really rough weekend, so let's talk to our guests, and then they can set me correct on why Windows is still a horrible experience.
And gets worse.
And gets worse. Thank you. Thank you for chiming in on that.
Welcome to the show.
Yeah.
Can you tell us a little bit about yourselves?
No, I guess we're done now.
Okay. I guess I'll start. My name's Mickey, and I don't know how to introduce I never know how to introduce myself, so I'll just be like, been doing this stuff for a lot of years, over 12.
Oh, man.
Been focusing on security research for a while. Spent 10 years working for Intel. 6 months in McAfee. Thank you.
Sorry.
Yeah, sorry, And since then, I've been in Eclipsium.
Nice. And Jesse, do you have anything more uplifting to say?
I don't know if I would say uplifting. I was just trying to do the math to figure out how long I've been doing security, and it just makes me feel old because I've been focusing on computer security issues and basically kind of going back and forth between offense and defense for over 20 years now. Wow. And I've started off kind of helping to build defensive software, then kind of went into reverse engineering and attack, and then kind of back to defense, and worked at Intel for, I think, 7 years or so. So I'm not quite as far along as Mickey there, but we ended up, as he said, we did meet together at Intel. We both went to McAfee also, and then ended up at the startup. So we've had kind of a interesting journey along the way, but mostly been doing a lot of reverse engineering, and writing exploits is fun. And I kind of go back and forth between offense and defense, and which is more fun.
So in summary, you've been doing this since the Teletubbies were a thing.
Basically,
and
yes.
Mickey's been doing this since Fire Phone was a thing for a hot second. Got it.
That's Jen's time bar.
That's my time bar. That's my cultural touch points.
So we were going to ask you how you met, but it looks like Intel.
I just kind of ran into that.
That's perfect.
So, yeah.
And were you doing BIOS and UEFI stuff back then?
To some degree, like I was in a. I was doing security stuff outside of Intel, and then I joined into basically a product security group inside of Intel that worked with different organizations throughout the company to help them improve their practices, and worked on a number of different areas, including looking inside the chipset and CPU at the RTL design level, and looking at the platform and different components that are on the system other than the things that are Intel's providing, including things like how the motherboard is wired up, what kind of third-party components would be in that. And Mickey joined the team that I was in, and we started working together, and we worked on a number.
It all went downhill from there.
Yeah, basically.
Well, were you guys coming like with two different specialties, or like?
I guess two different cultures, I'd say.
That too. Yeah.
I just
you want to
moved
elaborate?
To the US.
Like, so you did meet in Intel, where you guys just coming together from two different teams, and therefore two different angles.
Well, kind of, yes and kind of, because I
Okay.
just moved to the US
Uh-huh.
from a different Intel team, and I joined the same team as Jesse, and we both kind of started being in the same lab, working in the same team, doing the same boring work every day.
So you had lots of time on your hands, apparently.
Yeah, kind of
I
like
don't
the
want to presume to speak for you, but that's what
no,
you
no,
said.
no, the that's okay. I'm trying to be gentle when I'm describing this. The the mundaneness of the job kind of forced us into being creative and finding new ways of doing the stuff we like to do. So if you've ever experienced corporate product security, you'd know how
So
demoralizing it can be.
so a lot of idle cycles lent to exploration of creativity
Yeah, we would be tasked
jointly.
with a project. Yeah,
Yeah.
we would sit next to each other in the lab. It's a loud lab. There's long benches. You know how it is. Train benches. There's 8 people in a bay.
Okay.
Yeah.
So what happened to the other 6? Did you eat them?
No, we're still, some of them are still friends of ours.
Oh, good.
Some of them never were because they were part of a different team.
Okay.
Yeah, two of the basically the two founders of the startup that we work for, we also met at Intel and worked on a team with them. So I mentioned we were working in a product security organization. At some point, I was asked to lead a biosecurity team and kind of work on client BIOS as opposed to server BIOS, and work with the team for that. And um, Mickey was on that, some other people, and then Mickey and some of the other people we were working with had the smart idea of creating a different organization within the company to focus on more interesting projects. And instead of just working on product security within Intel, basically looking at other targets throughout the complete ecosystem, including other strategic targets, not just things built by Intel. And
Okay.
Mickey was a little bit smarter than me because he joined that team immediately, and it took me about a year to come to my senses and join the team as well. But that gave us some opportunity to work on some other things and do some other interesting projects. And that also, because the target was external research, there was more opportunities to start giving conference presentations and talks about and
Yeah.
publish the research we were doing.
That team was named the Intel ATR, Advanced Threat
Yeah, advanced
Research.
threat research team at Intel.
So were you still focusing on x86 and the like, or were you guys expanding into other areas on that team, even though it was all external product?
I think it was both.
Yeah, both. Some of it was about x86 products. Some of it was about like ARM and ARM, like some of the trust zone things. There was a fun talk that Mickey and I gave where we basically convinced our management in the ATR team to let us basically go to a nearby junkyard, and we bought the entire dashboard of a Nissan Leaf, and we were assembling the dashboard in the lab, and basically, okay, this connector has like 3,000 pins. It looks like this thing over here, and basically like
Yeah.
figuring out how it all hooked together and like trying to find other source of information, like forum posts where people were like, I swapped this thing out in my Nissan, and figuring out what we were doing there. But eventually we were able to find a fun vulnerability where it turned out that the telematics unit, the TCU telematics control unit, it's essentially a cellular modem in the Nissan Leaf. The old version was using the same chipset as the original iPhone in that nice vulnerability where it was I think it was, what was I don't think it was the very first iPhone. It was like the
3G or
3G.
Yeah,
Yeah,
the
the
3G
iPhone
chain.
3G, there was a nice Infineon chipset and a vulnerability that you could exploit this over the air by setting up a base station. The Nissan Leaf was using a Infineon chip in a telematics unit from Continental that was sourced through like this roundabout way where they didn't realize that they had the same vulnerability like 7 years later after this vulnerability was already public in the iPhone space. And we were able to basically get this dashboard up and running enough that we were literally getting cellular connectivity back to Nissan's private network using the cell modem. And then we also we decided we're not going to snoop around their network. All we're going to do is try and do attacks against it. And we basically were able to set up a base station in a Faraday box and do that's basically take the same exploit from the iPhone 3G exploit and land that on the TCU, get arbitrary code execution, and prove that it was vulnerable to the same thing.
That's pretty cool.
And we
That's amazing.
notified Nissan. It went a few other places. I think Ford, Infineon, and I think there was a third or fourth vendor that there were 4 different car manufacturers and model lines that were affected by
Nissan,
this.
Infiniti.
Is the assumption that it was a car,
BMW.
one of the third-party vendors was supplying this prefab part that was going into all of these models? That was the source of this?
So Infineon had sent out like information advisories about this at the time. Somehow Continental or someone else along the chain dropped the ball. So the manufacturer, Nissan, didn't realize that it was vulnerable to the same thing that had been public in different market segments like 7 years ago. So that's kind of the types of projects that we were able to do that's like completely unrelated to like x86 traditional PCs. So that was kind of a fun project. But
so was the team kind of the equivalent of Project Zero at Google, where you work on other companies?
Yeah, it was similar to something like that.
It was kind of, we didn't really have the mandate from management to do something like that. So we had a lot of pushback and a lot of politics and a lot of issues to deal with. Remember the Y gig?
Yes. Yeah.
That was a fun project.
What's that one?
There was once upon a time there was a technology that they came up with at Intel.
Was it Y modem?
It was called Y gig, and it was basically PCI over the air over 60 gigahertz.
Yeah.
So you would have you'd have like a wireless docking station. It would have 6 megabits per second. 6 megabits.
I feel like there was a bunch of companies like this.
It was a 60 gigahertz network link. So I think it had only a pretty short range, like maybe 6 feet maximum or something like that. With but the usage model was basically like you'd set your laptop down on a charging panel. You don't have to plug in any wires. It automatically connects to your dock, and your displays pop up on your 2 monitors on your desk, and you have an external mouse and keyboard without having to plug anything in. And it was a neat technology, but it basically, the way they implemented it was essentially they had a PCI bridge chip that converted PCI and tunneled it over the air over this wireless signal. And we did kind of a fun project where we ended up taking one of these docks, modified the dock physically in order to, like the bridge.
Every card would have every card would have 2 PCI lanes, an RxTX, but this one would have 2 pairs. There's one that's documented and one optional, and they used both. So
we made a custom circuit board in order to break out the additional lanes in order to have to insert basically like a DMA attack and do DMA,
the old FireWire Thunderbolt.
Yeah, DMA into a Windows laptop over the air without ever touching the laptop that was the target. Just like you walk up this modified dock, maybe like the classic hotel or the classic Evil Maid, where somebody has messed with your docking station at your office while you're not there. You walk in, you set your laptop down, it pairs over the air with and has DMA capabilities, and then you can do DMA access and steal secrets from memory and write to physical memory over the air without ever modifying or touching the target laptop.
And so this technology flourished. Because
Yeah,
I
as you
vaguely remember this in like 2005,
There were a couple
7,
generations of it where they had the first generation and then they had a second generation, but then I haven't heard about it in a bunch of years.
Yeah.
Yeah,
So.
I'll put a link to the Wikipedia article on the show notes, because I mean, it became, or it's a 802.11 AD AY, like it kind of includes some of the other standards, because I guess, I mean, now cellular is also going in the tens of gigs.
Well, I was going to say that,
but not DMA
right now, like
No.
in the 55, 60 gigahertz range is where they, not near field, not NFC. What's the other thing that the Soli stuff is based on?
Oh, I mean, there's a lot of the
ultra wideband. Yeah,
but yeah, I'll put links to these things.
But definitely has more range than that.
Yeah.
So
that was a fun project.
It sounds like it. So, I mean, we're just, stripping back all of your projects, especially the two that you just told us, how did each one of you, before you even met at Intel, how did you guys get interested in BIOS to begin with?
Well, I wasn't interested in BIOS to begin with.
Oh, no. Just like BIOS found you and recruited you.
I kind of, it's like quicksand. You just step in and it swallows you.
Yeah, that's fair.
Yeah.
I think my first experience with BIOS hacking was, this was a long time ago before I even worked at Intel. A friend of mine had an old, I think it was a ThinkPad laptop. There was an old legacy BIOS laptop, that it had it had a whitelist allowing which specific Wi-Fi cards you could use in the laptop. And a friend of mine wanted to swap a different one in and couldn't swap it in. So we spent a couple hours basically reverse engineering the BIOS in his laptop. It was like doing sketchy things like 16-bit mode and like 32-bit mode transitions, because it was an old style BIOS. And we did find the whitelist, like patch that out, and we were successful at fixing that. So then he could put in the non-approved Wi-Fi card that he wanted to. But that was my first experience with actually what is this BIOS thing? Let's reverse it and see what we could do with that and actually solve a problem.
Speaking of, what is BIOS?
Yes. So BIOS is essentially there's a couple different terms for it, and depending on how old the system is, you might see different things. But essentially, when the system powers on, the first thing it needs to know is, where is it going to load the code that it's going to run from? And there's been a kind of a standardized way that PCs have booted up basically since Intel x86, like the first x86 processor. There have been some changes along the way, but essentially the way that even a modern processor boots up, it still is kind of coming up in this special mode. It's loading instructions from, basically there's a SPI flash on the motherboard. It's a non-volatile memory. It's basically a chip on the motherboard. It might be an 8-pin or a 16-pin chip, depending on the package, depending on the motherboard. But that essentially has what's called the reset vector code that's run by the system. And in order to have a uniform environment that you can load an operating system and run things in a standard way on a vast variety of different types of hardware, laptops, you don't want to have like Microsoft or your operating system vendor do all of the hardware initialization just to even load the operating system for different types of laptops that might have different device drivers or different types of hardware. There's essentially what's called BIOS, basic input output system, is what it used to be called. And that was kind of a standardized way that the original set of PCs would boot the system. And there wasn't really, it was a pretty simple mechanism where the what was in the SPI flash would just do enough initialization of the hardware. It would go out and enumerate devices in the platform and like detect, okay, I have this much memory. Like there's the old quote of like 640K will be enough for everyone. But even back then, it's like you had different systems that had different amounts of memory. And then we had like gigabytes of memory. And then now I have a desktop next to me that has 128 gigs of RAM in it. And some of the servers have even more than that. But in order to figure out how to lay out memory and where to place things into memory, it'll go out and enumerate the hardware and talk to different hardware interfaces in a variety of different ways. Like there's a concept of I/O ports and memory mapped I/O, and there are certain things at particular I/O port addresses according to what's considered like the PC architecture specification, and what is like a PC-like device. Some things like laptops and tablets and phones kind of move away from that in a number of different ways. But if you have something that's coming up as essentially a PC, whether it's a laptop, a server, a desktop, it'll have certain things at certain addresses. Like there's what's called PCI device access at IO port CF8, CFC. It'll do IO port access. It'll set up things like enumerate some kind of the memory space. There's hardware registers in the CPU and chipset that are initialized for configuration of the hardware. And a lot of these things are done in order to get the system up to a state where like your memory is turned on. Like when the reset vector initially runs, you don't have any real memory yet. So before you can do things like call functions and push values onto the stack, you need to essentially enable memory. And some of that is just the hardware initialization that's done and writing to some of these configuration registers in the CPU and the chipset.
So I have a question for So I have a question for you. So is port 80 still a thing?
Yes. Port 80 is essentially, there's an IO port that is essentially used for kind of the status of where you are in the boot process. Some motherboards will have like a little like 8-segment LED display that'll show you the number of where you are in the boot process. And that can be really handy when things go wrong and you don't know what's happening, because if you have like bad RAM or something like that, it'll boot up to a certain point and it just detects that there's something wrong and it can't get further. And ideally, you'll have something that is writing the status. It's basically a 1-byte value that's 0 to 255 that gets written to port 80. And then if you have one of these little displays on your motherboard, you can see, oh, it stopped at like 43 or something like that. And that might not make sense to you just out of the blue, but a lot of times you can look up like BIOS codes or port 80 codes. And a lot of times there will be families of different codes where you can have, okay, if it's in the 30s, it means this. If it's in the 40s, it means this. And then different models might have additional codes that are not standardized, but you might be able to find further information that somebody has written up on a forum. There's a lot of interesting hacking forums where people will like take apart BIOSes to do things like add support for a whitelisted Wi-Fi card or some other hardware that they want to support, or do other weird things for their system.
So on your I'm not used to motherboards having that 7-segment LED on there. Like I'm just used to it like being a postcard that I'm used to it called a postcard that you would attach.
So yeah, there is a header on a lot of motherboards that you can attach a card to and have this 7-segment display. There are a lot of different types of connectors on the motherboard. There's something called an LPC or low pin count header. That's one of the ones that commonly has this port 80 out on it. Another thing that you might plug into the LPC header is like a TPM, a trusted platform module. A lot of times you'll have a trusted platform module on the motherboard. I think since, is it Windows 8 that they added the requirement for needing a TPM in order to support Secure Boot, or was that Windows 10? I don't remember.
I think it was 8. It was 8.
I didn't
1,
touch
maybe?
Windows 8, so
One of the Windows releases, Microsoft wanted to enable Secure Boot and enable TPMs, so they made it a platform certification requirement where if you want the Windows certified sticker on your laptop or desktop, you needed to have a TPM in the platform. And as part of that, they worked with Intel and created what's called a firmware TPM, which is, instead of having a discrete TPM either plugged into the LPC header like you were talking about, or a discrete TPM that's like an Infineon chip on the motherboard, the firmware TPM is essentially a virtual TPM that's implemented in the Intel manageability engine. And they basically have a hardware interface that between the host and the manageability engine in the chipset that looks like a TPM and provides the services of a TPM, even though it's implemented in the manageability engine.
Mm-hmm. So really, that's what the sticker actually covers, is just this extra functionality.
There's a lot of other stuff that's included in the Windows qualification, but that was one of the requirements that they added for a particular Windows version.
Okay,
and
got it.
So, I hear about BIOS. The name BIOS less and less. I hear more UEFI these days.
Sorry, I kind of got
No.
You went deep down.
way too deep into how the processor boots.
That's fine. Let's
that's part of the fun. That's why we do this.
But so BIOS and UEFI are both doing similar tasks, but back in the old days, BIOS is the old version or old name for the way that the platform boots and does all those tasks that I was describing. At some point when they were building bigger and bigger systems and like making more interesting servers, the idea and architecture for BIOS is kind of showing its age. It basically was written largely in assembly language. It had limits like there's the old style partition, master boot record partition, where you have like 4 partitions, and then you have like the idea of an extended partition, and you're kind of like layering things on top of that. And as part of that master boot record, you have like 512 byte boot code, and then that 512 byte boot code is then loading the next stage, what's called the volume boot record, from the first sector of your boot partition. That's not really a good way to implement modern systems. And one of the other problems that there wasn't really any architecture or way to do security in this. So it basically was like, I'm going to blindly load this stuff from the hard drive, the master boot record. I'm going to then blindly load the volume boot record. I'm going to blindly load the operating system. So there were a lot of viruses and worms back in the old day. And while that was a problem, that was not the primary reason that people ended up switching to what's now called UEFI. It primarily was like just supporting some of the bigger hardware and servers that they were trying to do. They were really running into some of the limitations with the old BIOS architecture. So Intel created what was called the Intel Boot Initiative. I think that was in like 1998 that they started this. And then after creating the Intel Boot Initiative for a few years, they worked with basically an industry organization, helped create what's called the Unified EFI firmware, or Unified Extended Firmware or Extensible Firmware Interface. And then they created the UEFI forum and basically donated their code from the Intel Boot Initiative to create this UEFI forum and reference code and specification to create what's now called UEFI, or I guess it was EFI, Extensible Firmware Interface, and then it became the Unified Extensible Firmware Interface. They worked with the industry organization that now I think has like 40 different member companies that are working together that build a new version of the spec. There's a reference implementation of this at Tiano Core GitHub. Tiano Core is the reference implementation. There's a EDK, which is the EFI development kit. And there's a couple versions of that. There was like EDK 1, and then they changed some interfaces to go to EDK 2. And every once in a while, they put out a new version of the specification. I forget what the current version of the UEFI specification is, but it's like 2.9 or 2.10 or somewhere past that, maybe.
Somewhere.
I haven't looked at
I can
looked at the number directly in a little while. But if you go to uefi.org, that has the UEFI reference specifications there. There's the platform initialization specification. Basically, they tried to make a much more modular, almost object-oriented method for creating BIOS. And instead of having, like, you might have seen, like, the original BIOS was doing like interrupt calls. So in order to read a disk, you'd like put some values in a register and then call int something in order to read a block from the disk. And UEFI is essentially a much more modular system where everything is booted up in mostly a much more reasonable environment. So there are still definitely a lot of problems with it, but it's a lot easier to write code for it. There essentially is once the system does that initial, the very, very early boot, it starts running through a few different phases. There's like the sec phase, like security initialization phase. There's the PEI, pre-EFI environment, and then the vast majority is a driver execution environment, or DIXI. And then there's boot device selection, BDS, and then there's the transition from basically the handoff from the UEFI bootloader to your operating system, and then the operating system runs. And there are still some UEFI parts that continue running past the operating system handoff, and we can talk about that in a little bit more detail. But
we don't have enough time.
Yeah, as part of this whole boot up process, there's they standardized on a number of things where there's more of there's a set of what's called boot services and runtime services. So when the system is booting up, there's also PEI services. So there is a limited number of PEI services, which is things like memory management, event creation, and signaling. It essentially is running like a single thread. So it's not doing like a multi-threaded operating system. It has a dispatcher where it will load and run different executables. These executables are essentially formatted like Windows executables with some small changes. If you've reverse engineered like a Windows PE executable, portable executable, there's some different headers. One of those is like the NT header. There's an optional header. One of the values in the optional header is the subsystem field. And the subsystem, a lot of times you'll have things like Win32 executable in that subsystem, or like a native binary. There's, I think, 5 or so different there's 5 or so different UEFI related subsystem values. So it's essentially PE formatted, but then you'll see something that's marked as like a UEFI boot services driver, or like a runtime driver. And you can use a lot of the same tools for reverse engineering these UEFI executables, but it'll have different like the entry point will take different arguments, and kind of the structure of how you do a call from one driver to another driver is done completely differently than Windows does it. But if you know about how these structural call patterns differ between the two types of executables, you can totally write your own tools, build tools on top of existing executables like IDA, Binary Ninja, Ghidra, a number of different tools that already exist.
So just really quickly, you mentioned, I think you might have already mentioned this, but if you were going to start doing your own development, would that Tiano Core EDK2 be where you would start, or would you start somewhere else if you wanted to start doing this type of development?
So I think if you're doing, well, there's development versus reverse engineering versus if I want to do something to my own personal laptop, and there's like various different types of approaches where you can take. There's one of the things that's kind of nice about the implementation at Tiana Core is that you can build different targets. You can build EDK for different targets. One of the problems for building for a physical device like your own laptop is that the kind of the supply chain for how all this code comes together is kind of complicated. And there's the reference code from Tiano Core that gets taken by a like an independent BIOS vendor like AMI Inside Phoenix. They add their own stuff on top of that.
Mm-hmm.
They then give that code to like a device manufacturer, like Lenovo, HP. They might have their own
or
vendor
single
that
board
does
computer manufacturer.
Yeah, like
or
board manufacturers might do their own stuff and then give it to Dell, Lenovo, HP, or some other vendors. All of these people can add their own code at different times. There's also platform specific and generation specific initialization code that is provided by Intel or AMD. Basically, the CPU and chipset manufacturer provide generation specific code that then is used to initialize the platform and gets all merged together with all this other code. And that all gets built and compiled and built into this image that gets written to the SPI flash that's on your motherboard before it ever ends up in your hands. And there's a lot of places where things can go wrong. There's a lot of different places where code can come from. You might, if you just take the reference code from Tiano Core, you probably don't have all the code that you need to build a working platform that'll run on your laptop or desktop. There are a few platforms that you can build all of the code, and all of the code that you need for the platform initialization is open source.
Yeah.
That's a good target if you want to do like physical exploration. I would also recommend, like, even if you can't directly write an image back to your laptop by starting from completely building everything from scratch, getting a SPI programmer, and I'll often use a DediProg. That's one of the common SPI programmers that we'll use. I have a DediProg SF100. Mickey has a 600 and 700 and does a lot more interesting things with the SPI programmers.
So you should get this equipment.
Yeah.
So you said this is DEDI Prog.
I'll have a link in the show notes.
Okay.
DEDI Prog.
Okay.
SF100 usually works. If you use that with what's called a chip clip, you can get a little clip that you can basically kind of clip on top of the chip on your motherboard, depending on the type of motherboard you have. I mentioned that the SPI chip might be in different packages. The easiest one is going to be a SOIC 8 or SOIC 16 package. But some of the more recent modern laptops have a SPI flash chip where all of the interesting pins that you want to get to are underneath the package, and it's a lot more of a pain in the butt.
Of course.
So for those, you can sometimes find test pins that are around, or like resistors, other things that you can touch.
Well,
with a probe,
I would assume you can still like pop it off. I think the next obvious question I was going to ask is, probably don't write, don't do host based compiling and write to, because that will end up very sad and short lived.
So I was going to say that the easiest to get to is the SOIC 8. If you can clip onto that, if you can read that, then you can use a tool like chipsec or a UEFI tool to extract the different components and see the individual executables that are all part of this combined image. ChipSec is a great tool that was created by one of the founders of the company and a bunch of people. The other, like Yuri created the tool ChipSec, Alex, Chip SEC on GitHub.
Mm-hmm. So Mickey, we haven't heard from you in a while. Do you want to say something?
Yeah, well, Jesse described how to get started with hardware.
Yeah, you can talk about all the spy stuff.
No, but you can. That's like if you have some money to spare.
I don't have any money. How do I do this? And I have $1.
Okay, how do you do this? You have $1.
Do you have a bus pirate?
Can I buy a bus?
Sure,
let's just say I have a bus pirate. We have a bus pirate.
Yeah.
Cool, okay.
They're expensive.
We interviewed that guy. He's
I got the new one right here.
Nice.
Got it straight from Ian.
Yeah, there's also Joe Fitzpatrick's Tigard. Tigard is a great programmer.
So if you don't have money and you want to explore UEFI and you just have a computer with enough cores, you can use virtualization. So a couple of targets that my favorite targets to use for anything to demo and to start prototyping any exploits or other work that I have is QEMU, which EDK2 has a way to build it. There's also an emulator built in that allows you to do that. I personally try not to use the emulator that it comes with EDK2 just because I want to get as close to real life scenarios as possible. So I do that, and the next step past that is using VMware. Now that Broadcom has bought VMware and VMware Workstation is...
Please, I tried buying it last week and they still have not confirmed that I've actually bought it so I can download.
They're terrible. But the Workstation is free for
non-commercial.
For non-commercial, yeah. So if you are using it for non-commercial, you can get the Workstation, and Workstation allows you deep breaths, Jen. The non-commercial allows you to specify an EFI file when you boot the system, and VMware is using a UEFI based firmware image that you can modify and play with.
Nice.
And they do support secure boot, so you can practice secure boot bypasses and stuff like that, which is fun. They do have virtualized TPMs that you can mess with that too, which is also fun. And you can learn. I like to learn by getting my hands dirty, and that's the easiest way to get it done
without destroying the little bit of hardware that you happen to have. I think that's the operative word.
Yeah, and the next step after that, if you do have some money, let's say you do have like $200-300 laying around, you can go shopping on eBay.
Yes, or you can go to the thrift store and get whatever old ass laptop that just happens to be there. For
we still need the hardware to talk to it,
right? Oh yeah, that's right.
So
DediProgs on eBay are fun to get.
I literally found one at work today.
Oh, you did?
Yeah. It's like I haven't seen this before, and I'm like, oh wait, that's exactly I will point folks to your DEF CON 30 talk. I'm gonna put a link to it there, where you go into like pretty deep dive into all the secure boot bypass stuff, right?
Yeah, that was a fun one. When the one bootloader to load them all.
Yes, that was fun. I watched it over the weekend. One thing you did mention in the talk is that there's right now you mentioned drivers and other stuff. There's a lot of code that runs before the operating system these days. You have some examples of like weird stuff that we might not expect, or what some of your favorites
besides Post?
Yes, no. So you mentioned our DEF CON 30 talk. We also gave a pair of talks in 2018. One at Black Hat, one at DEF CON. I think it was DEF CON 26. Where we talked about we actually talked about a number of interesting things that we found in BIOS, including like the main talk that was about update mechanisms that we saw in BIOS, where traditionally updating your BIOS has been difficult. Like it's not as easy a process as like Windows or Linux or Mac updates. Like operating system updates generally are a lot easier to do, but all the different vendors have been making their own ways to update BIOS, and we found a couple interesting ones where before the operating system would boot up, the UEFI firmware can bring up the network stack. So one of the things to know is that in addition to just setting up hardware and configuring it and loading the operating system, there's a complete network stack in UEFI. It can bring up the Ethernet interface. It can do like web connections. Some UEFI firmware will have Wi-Fi support. So before the operating system even loads, it could potentially bring up your Wi-Fi card and go out and talk to devices on the internet. Some UEFI firmware has Bluetooth support. So
why not?
Bluetooth that's running.
There was the crazy one. There was a dehumidifier.
What?
There was a
Wait,
BIOS
first of all,
feature.
why was it running BIOS at all? Why was it?
It was a feature in BIOS.
That's right. Yeah. So it was a
BIOS
motherboard
feature
that could enable and disable this dehumidifier circuit on the motherboard.
It was a way of like using the temperatures of the CPU and the motherboard to create the dehumidifying effect. It was way out there. I don't think we've ever seen anyone ever use it, but we saw the code and the mention of it.
Yeah. One of my favorites though was we found a BIOS UEFI firmware that had a SMTP client in it, and it could send email from
the BIOS
UEFI firmware before the operating system loaded up. So this was intended as essentially a way to provide a support package to the vendor. And one of the cool features is that you could mount your C drive, attach any file you wanted from the C drive, and send that as an attachment as part of the email
before booting
to the manufacturer. And we found like hard-coded email addresses. I think
Passwords also?
Yeah, I think we have found some passwords. There was an FTP client where you can upload stuff to an FTP server. If I remember correctly, one of the vendors that we were trying to disclose things to. So, like as you know, like different software makers have different security maturity. Hardware vendors are all over the place. Like
Jesse's being really nice.
The big ones like Dell, Lenovo, and HP, they've been doing this a while. They know a little bit better about what they're doing. They still have their own problems, but it's like I feel some of the smaller ones, it can be hard to even find who to report an issue to.
Well, absolutely.
And if I remember correctly, Mickey found a customer support email in one of the BIOS images and was basically emailing that person, and they were relaying our reports to somebody else around the world to try and
it was insane.
Get us connected to the right person.
I was emailing a guy in San Diego, and he would be communicating with Taiwan.
Yep,
and
that's
he's
right.
Communicating with them and replying to us in English, and basically telling us what the mothership said.
So what you're saying is that hardware vendors really push and explore the boundaries of security and privacy.
Yes.
Security? So what is that?
Those two talks that I mentioned, we did cover a number of different areas like SMTP in email. There's different ones that will download and execute, like diagnostic tools over the internet.
Yep.
There's a server manufacturer that has a provisioning feature built into their servers where you can basically select what type of operating system image that you want to install, set up your configuration, and provision the server like as this one-touch process. That involved basically booting up an embedded Linux distribution that's built into the server that ends up doing things like running an embedded web browser with JavaScript and doing other sketchy things
before the OS.
Of this whole process, as essentially was an alternate operating system boot path.
So and specifically what we're not even talking about the one that you did, because I can't find. You said I think DEF CON 26, right?
So there's
it's all a blur.
Remotely attacking system firmware, and then there's also UEFI exploitation for the masses. So there was a kind of a different focus between the DEF CON and Black Hat talk.
Yes.
DEF CON was kind of describing some of the same things, but going into some more details about how you can do this yourself and some of the things that you might run into when you're trying to debug. Like if you're writing an exploit for one of these bugs, how do you debug it? And this is like you don't have GDB in the pre-boot environment like this. So there are some hardware debugging tools that you can use. There's a Intel System Studio. There used to be, like back in the old day, there was this big like 60-pin XTP header that you would have to plug this $3,000 debug port or debug pod into this, and then use this tool with Intel System Studio or Intel Debugger to halt the processor while it's booting up and get breakpoints and things like that.
Yeah, this thing.
I will say that when you say $3,000, that sounds positively cheap compared to what I remember. I could have sworn that we're talking like $7,000 to $10,000.
Oh yeah, there are some that were like $15,000 for
like
some
the Lauterbach.
So
yeah,
eBay,
the Lauterbach. Oh man,
yeah, like Lauterbach. That was one of the ones that was pretty expensive.
So
at some point after this, they basically switched to using what's basically DCI or a direct connect interface, and it's essentially a mechanism for tunneling JTAG over USB. So depending on the generation of platform that you have, you might be able to use a special USB cable between a recent enough host and a recent enough target to debug a host platform under some circumstances.
One note to that, since that talk that we gave at DEF CON, that was the point of it was to get everyone get started, like it's a startup guide 101, how to get hardware debug. Since then, Intel has moved the Intel System Studio under NDA.
Ooh.
So you need to
So I can't go to eBay, is what you're telling me.
Well, for the USB debug on Intel platforms, you don't need to go on eBay. You just need to have a dedicated special USB cable.
Okay.
You can get it off DediPro for $25 or $15 in Seattle.
Okay, so that takes care of the physical hardware, and
the
then
physical
for
hardware, but
the
software
studio itself, I just need to make friends.
So either you get friends, or you can find some places on the internet still have the Intel System Studio 2020, which was still public. So you can use that up to the 10th or 11th gen Intel processors.
Are there any open
bit savers, basically?
Any open source or any projects trying to reproduce that?
Good question.
Not that I'm familiar with. I wish there was.
Yeah, it seems pretty complex. Like if you don't know what the processor details are.
Yeah, there are some projects that have been doing reversing some of the Intel things. So
I think Peter Bosch did something with that.
Yeah,
with the BSSB, but I don't remember. It was, and then he started working for Intel.
So you said Intel, but you said that Intel wrote the software. So if I go look here,
Intel System Studio 2020 version 3. I think that's the latest one that was public. That has a public, a non-NDA debugger version.
I'm just trying to see if I can find it on BitSavers, though. No.
That was going to be one of my questions, right? Like, how do you instrument and debug UEFI? So one of these DCI, it's literally JTAG for your Intel processor, is what you're saying, right?
So essentially there is JTAG. It's similar. There's some extra things, and there's different levels of. So there's like unlocking a chip, and if you just plug it in, or so there's some things with like enabling the JTAG port and enabling CPU debug.
We go into that into detail in our talk.
Yeah.
So the talk was basically how to set it up, how to get it running, all the settings you need.
And the other, you mentioned virtual QEMU.
Yeah, QEMU you can do GDB.
So then you could just step through the code and
and also VMware.
Yes. So depending on the target, different mechanisms for doing debugging will work better than others. Like if there's a particular like vendor specific or platform specific thing you're trying to reverse engineer or modify or get an exploit working against, it might work better with hardware debug with the real physical platform. If it's a somewhat isolated module or driver that you can run in a virtual environment and then debug it that way, that works great. You can enable things like GDB against QEMU and VMware. There also is just good old prints. Like if you're modifying and recompiling your own executable, sometimes just like print I got this far. Print I got this far. Here's this value. Like that's a very common thing but you do have a variety of different options for which mechanism is going to work best for your particular scenario.
And is it all in C, or what's everyone writing these things in?
Most UEFI is written in C. I believe there are some efforts to do some Rust in UEFI. That's kind of a cool process. One thing that you will run into though is like the vast majority of code in UEFI is written in C. I mentioned that there's a lot of programs that can run in addition to all the different weird things that we talked about. Just a standard laptop can have like 300 different executables that are all individual executables that run an individual part of the process. Like there's a TCP executable, there's a DNS executable, there's a UDP executable, there's all kinds of different drivers. There's your when you go in and hit a key and go into your BIOS UEFI setup page, that's going to be a different executable.
All of these live on SPI Flash, or is any of this store on the host on the hard drive?
So there's the SPI Flash will have the vast majority of your UEFI firmware. On the hard drive or SSD, you'll have what's called the EFI system partition. That's where your bootloader and some additional applications like that are stored. So you might have like a recovery application, you might have memtest, you might have your operating system bootloader, you might have a few different things like that that are stored in the EFI system partition. When the system is booting up, there's a dispatcher that runs all these things in order, and then it gets to like boot device selection, and then finds the EFI system partition, and then loads things from well-known addresses or certain configured locations from that EFI system partition or elsewhere in order to you can load a driver before your operating system, and then load the operating system bootloader, and then that handoff happens, and the operating system takes it from there and continues on the process.
Yeah. On that note, like there's one of our past interns, Stas, and he's working on generating a tool, and we got accepted to speak to present it at Arsenal in Black Hat this year, and it's called Damn Vulnerable UEFI.
Nice.
And the whole purpose of it is to give anyone an environment to experiment and explore UEFI vulnerabilities and exploitation.
Oh, that sounds awesome.
Yeah, and that would include QEMU and some VMware notes and all the known methods that we've experimented with to play with and set all that up. So, just be a damn vulnerable framework, like the damn vulnerable router, damn vulnerable SQL server, damn vulnerable web server. Similar concept, but in UEFI. So you can just download the GitHub, use the Docker, build ADK2. It's all.
So we should keep an eye out this summer at some point.
Yeah, it will be released during Black Hat.
Oh, perfect. Yeah, so early August.
Yeah.
And we had some questions from listeners. If you're able to run stuff, before the operating system, is there like an active demo scene for BIOS or UEFI hacking?
Well, what have we seen? We've seen someone build Doom for UEFI.
Yeah. There is a version of Flappy Bird for EFI that we played around with, but when we ran it on a real physical system in our lab, it ran way too fast. Like the timing for the platform was off, and it was written in a hand-coded assembly language, so I didn't want to spend too much time debugging that. But yeah, we have seen a number of different.
Oh yeah, there was a single EFI binary for Linux. It was 26 meg binary. I
And it's
think
just
they have
Linux?
coders doing all of these things. Yeah.
That's
Tetris and all kinds of stuff.
I saw a recent. I think there was a talk. I forget what conference. Basically, there's the idea of like a self-replicating program, and somebody made a self-replicating program for UEFI, and like gave a talk about that recently. I forget what conference it was, but that was kind of.
I know who you were talking about, but
Yeah.
I forgot his name, and I don't want to butcher the pronunciation.
And you mentioned demo scene and running Doom. Like one of the interesting things that we've seen in the space that's been happening and getting more of a thing in recent years is game hacking and game cheating.
Yeah.
So like there's all of the like protections in the operating system and like all these like different kernel level drivers that will load and run and try and detect game cheating. People have started making UEFI cheats that will then load before the operating system and then patch things in ways that the game cheat detector that shows up later has issues with. So there's a active like UEFI game cheating scene where there's commercial executables where people will pay money for a variety of different UEFI game cheats, including things like aimbots. I had mentioned that there is code that runs after the operating system loads. So kind of getting back to some of the ugly details of PC architecture in general is that so there's different privilege levels within the processor. There's essentially ring 3 is user space, ring 0 is kernel space, and user space isn't supposed to be able to do things to compromise, or user space isn't supposed to do things to compromise kernel space. But then there's also a more privileged level even below that called system management mode, where this is something that was initially designed for platform manufacturers to be able to do extra hardware specific tweaks and things to support weird hardware, but it's evolved into more than that, and there's essentially code that continues running in system management mode, and there's a concept of a system management interrupt where you can have different events that cause a system management interrupt that will then interrupt even your operating system kernel to go into system management mode, do some things, mess with the state of the system, and then return to the kernel, where the kernel, even running in kernel mode, it cannot look into system management mode to see what's going on there. And when the system is booting up, there's a piece of your physical memory that's set aside for system management RAM. They put system management interrupt handlers in there. Different drivers can register a system management handler that gets put into system management RAM, and then that gets locked down before the operating system is loaded. And then after the operating system is loaded, things that happen during system management interrupt handlers can mess with kernel memory, and the kernel can't see what's going on in SMRAM. It can potentially detect some of the effects of things that happened, but it's really kind of a cat and mouse game if you have like Windows doing patch guard and trying to detect modifications of its own kernel versus something in SMM disabling patch guard and then patching things out so you can then have your aimbot or whatever that runs and lets you win at some like multiplayer game.
Shout out to Unknown Cheats and all the posts they have there. It's just amazing. If you ever want to go deep diving into all the technical information you can ever think of, go look at the
Unknown Cheats is great.
Unknown Cheats is a lot of good people up there.
Yeah, I don't know if it was you or someone posted a meme that if one of the best people to ask about Windows internals is game hackers.
I think it's I think if maybe Alex Ionescu said that at some point.
Yeah, somewhat like an 11-year-old.
No, yeah, it was. I forget who said that, but yeah, definitely, it's going to be like a 17-year-old on a game hacking forum is going to know way more about
Holy
Windows
crap.
internals than basically anybody on the planet.
And that's pretty
Yeah.
much like the
Yeah.
number one reason why we hear often why people get involved into reversing to begin with. It all starts with toys and video game cheats.
For
Yeah.
me,
It's
it was
getting something. Yeah, sorry,
Hmm?
go ahead.
Oh no, yeah. For me, it was just game demos back early 2000s.
Yeah.
You download a demo, and I found out that it had all the levels. It just locked in one. So I figured out how to just rename directories. It's like, oh, this is now level 1, and it would let me
Boom.
play level 2 and 3.
Yeah, getting it. It's always starting on getting something that you think you deserve, but you've been
For
kept
free.
from.
I don't think
Not
we
necessarily for
reference
free.
it that way, but that's a very Israeli way.
Well,
of
as a
explaining
kid,
that.
I couldn't afford it. I didn't want to ask my parents to buy another video game, so it was just download.
You mean
the demo.
shareware or vaporware? We're never sure like how much you're going to get from that game anyway for the price that they're charging. So yeah.
Yeah, and these days with the anti-cheat also. So as much as the cheat community is advanced, the anti-cheat as well, like Vanguard and their TPM stuff, it's amazing. It's just interesting, super interesting to read and see how they battle each other and how they're trying to solve this problem where they're trying to detect the anti-cheats, trying to detect fake TPMs.
Yeah,
and the cheating community is trying to create fake TPMs.
I'm not involved in any of this, but like, are we talking like just cheating in the game mechanics, or are we talking about cheating in the economics, like getting like basically black markets sale of things, or what?
Well, most commonly, the famous things are the esports. That's where the money's at.
Yeah.
So it would be tournaments and ranked games where mostly FPS, first-person shooter games, and what's the kid playing? What are the kids playing these days? Fortnite, Roblox. I don't know, League of Legends, whatever. All those.
Counter-Strike's the classic, right?
Yeah.
CS:GO.
Are people still playing that?
Oh yeah,
yeah.
I would assume it's like we're done with World of Warcraft and all that stuff.
CS:GO is still huge.
Some things never die, and
apparently,
yeah, it's amazing that they have hardware cheating kits with DMA that are now being detected by anti-cheat. It's like, forget about EDR, forget about viruses or nation states. Look at the cheat community; they're like 10 steps ahead of everyone.
I mean, a parallel that we've covered before in the podcast is the third-party toner and print cartridge.
Yes.
Yeah.
The amount of before that it was the pay to watch TV, like the cable cards,
pay-per-view, yeah.
And then that transition over to printer toner and the printers trying to detect if it's a legit cartridge
and coffee.
or not.
Don't forget all the coffee and the Juicero.
They don't spend as much money on those, but the printer ones, it's a lot of money in that.
I hate to say this, but who's printing anymore? And I do say that as someone who still prints. But
I have a 13 by 19 photo printer right behind me. So.
Oh, nice.
That's kind of fun.
I have a brother that I found on the street.
And what about your sister? Did you also find her on the street?
I also have a printer. No. Yeah.
We also have a brother. But like...
yeah. It's like
the way you said it.
The perfect way of duplicity. That's amazing.
So let's see. Oh, yeah. Another question we had. It was the last time I was actively involved with PC architecture. They still had a north and south bridge. How much of the BIOS or UEFI is still active after an OS starts booting? I guess that's part of what you answered, right?
That's basically SMM. So there's code that stays persistent in system management mode. There's also what's called runtime services, where most of the runtime services. So I mentioned there's boot services, which is mostly what executables are using while they boot up the system. That has things like event management, memory management. There's a concept of protocols. That's something in boot services where you say locate protocol and like install protocol. That's the primary method that different modules will kind of find capabilities that they want to use. But there's also runtime services, and runtime services has things like they've added support for what's called a capsule update. That's essentially trying to standardize the way that you do updates for for BIOS and UEFI because it's been such a mess. So there's a concept of a capsule update. That's something that's in runtime services.
So going back really quickly for protocols, what exactly counts as a protocol? Are we talking like audio services? Are we talking?
So basically any type of capability that you might want to have, like there's a block device that provides a hardware. You would have there's a way of registering a protocol saying I support this particular protocol interface, and then that's identified by GUID. It's basically a 128-bit unique number that you can say I am the handler for this protocol, and this protocol has a published or well-known interface to do things like read and write a file system. And then I have a block device that says I'm providing an abstract way to read and write blocks of this hardware device. Like
it's easier to think about as like a class or an interface, but it's just called protocol.
It's essentially like an way of doing object-oriented programming where you have an interface saying I can provide these capabilities and something else when it's like I want to read from a file system. I don't need to do all that myself. I go look up all the file systems and then I talk to this file system interface. That's all by locate and install protocols.
Yeah, I think what I'm trying to get. Yeah, I'm trying to like reconfirm is that it's different than what it used to be in BIOS, which is like, hey, at these established ports, you should expect if they exist and respond, then you have that capability as opposed to querying for the objective capabilities.
This is essentially like an object mechanism for saying, I have this capability, I'm going to register this capability, and then it's a much more modular way of implementing this. So EDK and Tiana Core will have specific GUIDs that are supported, specific events. So you can have an event that says, like end of Dixie, or I guess ready to boot is one of the things that happens right before your operating system boot. So I can register a callback that says, let me know when ready to boot is about to happen, and my code gets called.
And is the OS calling into EFI on the regular or like to do normal system stuff, or is this kind of a sometimes?
Like once you set it up,
one thing that I didn't really talk about is like we have the old idea of like a CMOS and like your coin cell where you'd remove that, your settings would be stored in this little coin cell backed memory. A lot of that configuration is now stored in what's called UEFI variables, and there's a few different types of or different attributes for UEFI variables where there's non-volatile variables. Those are stored in the SPI flash on the motherboard. And then there's variables that are not non-volatile. These are things that are configured, and like your BIOS boots up and it sets a variable that's not persistent in order to have something with a particular name that something else can use later. So you can have like a secure boot is one of the things that we also haven't talked about, but that uses things that are stored in UEFI variables for the key hierarchy, as an example. So your motherboard will have a platform key and authorized keys that are that executables that it's loaded for your operating system and other places are verified using these cryptographic keys to say if it's allowed or not. So if you modify the bootloader and secure boot is turned on, ideally, it should detect that. There have been a lot of bugs related to secure boot bypasses.
I will point again to your DEF CON 30 talk as to how to bypass.
Well, I'm just gonna. Well, I think the one thing that like as a practical question is that and usually when you're in UEFI, occasionally you have like a toggle like to like lock or unlock. Changes or whatever. What exactly is happening? Yeah.
So you can enable or disable secure boot.
Yep.
There's a lot of different toggles, different places. If you're in the secure boot setup, you might have something as far as like provisioning your own key. That's something that you can do where it's like if I don't necessarily, I'm not running Microsoft, maybe I want to modify the kernel myself. Maybe I'm running a custom build of Linux. I can provision my own keys into the platform and then use those and turn on secure boot. But yeah, there's a concept of these UEFI variables that these values are stored in the SPI flash itself. Some of them are used for configuration. If you change a setting in that BIOS setup, like enable or disable secure boot, that's going to change a value in a UEFI variable. And there are some permissions as far as what entities can change those variables. So one of the attributes for a variable is this a boot service variable? Is this something that's accessible during runtime services? So one of the boot services functions is like read and write variables. And then once the operating system boots up and you have runtime services, one of the runtime services is reading and writing these variables. And depending on the attributes of the variable, there are operating system functions that, like Windows has an operating system function that you can use to read and write variables. That essentially goes through a detour through what's called runtime services. That triggers a system management interrupt. The system management interrupt will check the request to see if you're allowed the permission to read and write this variable. And then if you are allowed to write to the variable, it will basically write to that value to the SPI flash contents itself. One thing that I didn't really talk about is the chipset has a lock to protect the SPI flash contents. So because the early boot code is coming from the SPI flash on the motherboard, if you boot the system up and then from the operating system you can just read and write to the SPI flash, you could potentially modify that early boot code, and that would effectively be a privilege escalation where you are modifying code that runs earlier, and in a sense, code that runs earlier has more privilege than code that runs later in a kind of a generalized sense. But there are also locks to protect that in the hardware. So at some point while the system is booting up, if the UEFI firmware is implemented correctly, it will set certain locks in the chipset to basically lock the SPI flash contents. So then after that certain point, ideally before it loads the operating system, that will be locked. And then if you want to do a modification to the SPI flash, you basically need to go into system management mode to unlock the SPI chip and get around that lock. So that's one of the mechanisms that system management mode is used for, is being able to do some writes when you need to the SPI flash. I had mentioned the boot process. One of the things that comes up when you're doing boot device selection is there's a UEFI variable called boot order. And that has like a list of what is the order that I'm going to try all your boot options. And then there's a series of boot options like boot 000, boot 001, boot 007, or whatever. And then when it's doing boot device selection, it will look and see what's the first value in the boot order. And maybe that'll be a value of 6. So it'll then create a string that is boot 0006. It'll look for that UEFI variable. If it exists, it will then look at what's called a device path, which has basically a UEFI focused definition of following the hardware to find, okay, here's my hard drive and partition, and then the file name is one of the types of device path you can have. You can also have a variety of different types of device paths, including one that points into the firmware in the SPI flash. You can have a device path that is an HTTP request across the internet.
Netboot. Network boot, right?
Yeah, network boot is another thing. So you can have a variety of different device paths in this boot order.
Yep.
And those are stored in UEFI variables. So from the operating system, you can change those boot order and boot device or boot variables. And then if you have a way to bypass secure boot, you could just modify the variable and like set your bootloader to run before the operating system bootloader. So
Yep.
If secure boot is turned off, you don't even have to care about that.
It's a
It'll just run
free-for-all.
your code and do whatever you want before it loads Windows. But we've run into a number of vulnerabilities. There was a fun one that we did about bugs in Grub, where we found basically since they supported secure boot in Grub like 10 years earlier, there were basic buffer overflows in how they parsed the configuration file for Grub, where you could get arbitrary code execution during the boot process with these signed versions of Grub, and then run whatever you wanted and bypass secure boot at that point.
Is Grub still heavily used? Or
Well,
yeah,
Grub
like
too,
every Linux
right?
distribution uses
Okay,
Grub.
still.
Most use Grub. I think there's some that probably use a trimmed down version, but essentially,
Okay.
I use that to boot this machine right now.
yeah. So there's essentially the secure boot platform key hierarchy that's in the motherboard, SPI flash. There's a whole key hierarchy that I won't get into, but those keys are used to cryptographically verify your bootloader and other UEFI executables that are loaded out of the EFI system partition and other places. There is a revocation list for that. So
is it actually checked?
So the reason that we looked into this and found this bug in Grub in the first place is that there was a Kaspersky bootloader vulnerability, and there was an update to this revocation list that went out through Windows Update, and suddenly systems weren't booting up anymore. After they took this update through Windows Update, there were issues where things would hang, updates would fail, and Microsoft pulled the update like less than a week later, and there was kind of a pointing match between Microsoft and Kaspersky about whose fault it was, and there were some press articles about this. We were like, this is interesting. We should take a look at this code, because
maybe there's something there.
There weren't really that many updates that had gone out to this revocation list before, and I think this update had tried to add 5 entries to this revocation list, and that revocation list it goes through a not very commonly used path of UEFI code. It's then stored in a UEFI variable on the motherboard. And we're like, if it caused this much trouble, we should look at this. And we found these vulnerabilities in Grub. And there was this whole effort with a bunch of other people. We ended up with, I think, the next revocation list update that went out after that was disclosed. There was like 250 new entries added to the revocation list.
Oh no!
So it was a bit of a stress test, and there were problems where some of the cloud infrastructure, because of the size of the revocation list, couldn't handle that, and people were having systems not booting up properly in the cloud that they didn't expect.
Yeah, I could totally see the revocation list and on older systems, like, oh, it's not going to fit on the SPI flash anymore. And
so
how does it even check for that?
There was a limit to the size of a variable that you could have. So there was a lot of scrambling to try and improve that whole process. But sometimes you run into interesting things by like, oh, wait a second, there was this news article about this update that went wrong. I need to go look at that thing.
So how do you find out about these things? Are there UEFI mailing lists, security lists, or just the news?
Yeah, there is a UEFI mailing list. That there's like EDK Devil is one of the mailing lists that people have discussions about. There also is just the GitHub that you can look at. There have been more talks. We've tried to talk to, like, we've been trying to help people start looking at this in more depth. Like one of that talk we mentioned was like, here are some hand-by-hand UEFI exploitation for the masses. Is like, here's how to get your hands dirty and start doing this yourself. One of the things that's really interesting is that, like, there's been this whole cat and mouse exploitation and then mitigations, and exploitation and mitigations in the operating system and application level. UEFI is kind of trailing behind in that sense, where in most cases, even today, like, things will load at predictable addresses. Like, most systems don't have address randomization to the same degree that the OS would, like operating system and applications will. a lot of times you'll have a fully executable stack. Like it's a lot easier to write in a UEFI exploit in some ways, but then it's also a lot harder to debug it in other ways. So it's
like most embedded systems.
Like getting people into how do you even get your hands dirty in the first place is something that we've been trying to help people with.
Speaking of that, one of our questions was, what are some beginner resources for BIOS UEFI reversing? I mean, I say the first one is going to be the UEFI exploitation for the masses, right?
Yep.
Yeah, I mean, there's the upcoming damn vulnerable UEFI that Mickey mentioned. That'll be kind of fun and give people more of a hands-on environment to do things. There's some nice training material. I think Xenokova has a bunch of really good
free training
material
online
to work through. What do you have some other suggestions other than that, Mickey?
There's for Ghidra, there's EFI Seek.
Yes.
It's a plugin that allows you to quickly map known GUIDs to known protocols and allows you to go through the code. IDA has EFI Explorer. Binary Ninja has built-in EFI protocol that they added recently. My personal favorite is Binary Ninja, just because it doesn't cost you an arm and a leg,
and it's useful.
I like Binary Ninja a lot. I have been using IDA for so long that I still find myself doing a lot in IDA, but I do like Binary Ninja a lot. I think the APIs and the scriptability of Binary Ninja is a lot better integrated than IDA in a lot of ways.
And it's better than Ghidra in the sense that it's not Java.
Yes.
I thought you were saying and there's undo. No. That's
I do have the sticker of
I also have that sticker too.
No undo, no surrender. But then IDA finally added undo, which is a little weird. I'm not really used to it.
What are you going to do with the sticker?
That's the beauty. You don't have to use it.
Still refuses to undo.
Right.
Yeah.
No, I guess
I
you
am pretty paranoid about making sure I save my IDA database before I do anything that might be sketchy.
So, do you save it as a new file name, or you just save it in the current one?
Version 2.
I usually just save it as the same file name, but sometimes I will save a separate one.
Okay.
One other question we had, and I think you mentioned it earlier, was the Intel Management Engine.
Mm-hmm.
Is that a separate processor that's communicating with the EFI, or is it? What?
Yeah. So essentially, there is this out-of-band management engine built into the chipset that provides these management capabilities on some of the enterprise class devices like vPro. There will be AMT, active management technology. It's essentially out-of-band management for a corporate environment where you can deploy updates and do other management tasks through this AMT feature. It is fully this isolated processor that runs Intel signed code in the chipset, and it does communicate with the main core in the processor. So there are a lot of different processing environments that you wouldn't expect. So everybody thinks of the main CPU as that's the CPU, that's the processor, but even with more modern systems, we have little cores and big cores and performance cores and energy efficient cores. For a long time, there's been essentially a small processor that runs in the chipset. I'm referring to the chipset. There's a officially the name currently is Platform Controller Hub that has things like on a desktop you have the main CPU package, and then on the motherboard there's the chipset. On a laptop, those will be two separate silicon dies that are within the same package chip on the laptop. But the chipset is essentially Platform Controller Hub. You had mentioned Northbridge, Southbridge. Back in the day, there was the Northbridge and the Southbridge, and the Northbridge was basically a memory controller, and the Southbridge was I/O controller. And then those kind of shuffled around, and now memory controller is part of the CPU, and then the I/O controller is part of the platform controller hub. But there's essentially an isolated executable or a processing environment that runs this manageability engine. It's called it's had a few different names, like manageability engine, converged security and manageability engine, security engine. So depending on if it's a server processor or a desktop, like a client processor, which is like a desktop or laptop, or like a smaller
innovation
client,
engine and servers.
like an Atom processor.
And
like an Atom processor will have different flavors of this.
Is there an AMD equivalent to this?
Yeah, so there is what's called a platform services processor in AMD as well.
Why did they have to make them separate, like two different things? Because it seems like, for the most part, most of x86, it's like they always try to unify everything. So why would there be
there's
a need
the
for
host
separate?
part, like that architecture that they try and unify, but they do have kind of their own way of differentiating and doing different services. So they do fairly similar tasks, but some different things. There, in addition to the manageability engine, there's also like power controller, and that is running
PMC.
its own, that is another, it's like PMC, power management controller. That's also in the chipset. There's also P unit in the CPU. Those are all separate, isolated environments that are running code that's signed by Intel or AMD in the case of the platform services processor. But those are all interesting places that people have been doing research. So there isn't a way to remove the manageability engine per se. There are some projects for like ME Cleaner. There's how much of the, so to kind of describe the SPI flash contents in a little more detail, there's what's called a BIOS region in an Intel platform. There's the BIOS region and the ME region. There could be like an embedded controller on the motherboard. There could be a gigabit region. Those are all different regions within the SPI flash. In the SPI controller, there's different permissions for these different regions. In most cases, if the system is configured properly, according to Intel specification, the host processor cannot look in the ME manageability engine region. It will load code from there. It has its own data region from there. If you have a physical SPI programmer like a DediProblem, like we talked about, you can click on there and then you can read the region, including the ME region that is protected theoretically from the host. Within that ME region, there's a lot of different code and data that it doesn't use the same format as the UEFI side, but there's a lot of interesting stuff that you can take apart. There's a great GitHub tools repository by one of our coworkers, Plato Mav, PLATOMAV, that he has a lot of stuff on GitHub for taking apart different types of BIOS images, taking apart the manageability engine image, taking apart microcode patch images, things like that. So there's a lot of great resources at his GitHub. But if you use this like ME analyzer that he's put together, you can break it out. You can break out the ME region into a lot of different executable code regions. There's data regions. There's this. Not all of these regions are required to boot the system. So there's an ME Cleaner project where people have made effort to figure out, okay, if I remove this region, the system still boots. If I remove this one, it doesn't boot. So I guess that one's required. So kind of limit it, like figuring out which ones you can remove and still get away with, and the system will still boot. So if you have a physical SPI programmer, you might be able to use the ME Cleaner to remove some of these extra code regions, flash that back to your system, and have the system still boot. So that's definitely something to take a look at and play with as well.
Very, very neat. And we're going to have links to all these things on the show notes. Another thing somebody else mentioned was core boot ?
What's up with that? I guess.
Yeah, so core boot is essentially alternate way to boot the system other than UEFI.
Mm-hmm.
It's more commonly used in things like Chromebooks. Chromebooks will basically boot up as core boot.
Okay.
Some systems will have like a compatibility layer where like it's running core boot under the hood and has like a UEFI emulation layer to at least boot up the operating system and let that run. Back when the transition between legacy BIOS and UEFI was happening, a lot of systems had a legacy layer like that where it was really a legacy BIOS and had a UEFI emulation on top. Now we'll often see what's called the compatibility support module, where you have a UEFI BIOS and it has this, if you enable the compatibility support module, that provides enough legacy BIOS stubs to boot the system and then run your
older
old
stuff.
legacy operating system on a very modern platform.
Or just a flash
But
boot.
some systems that have core boot have a similar type of mechanism where you can boot a UEFI operating system even though it's core boot under the hood.
Okay,
I've
so
done
it's a
some
whole
stuff
other
with
thing.
core boot. I've not done as much with core boot as UEFI, but it's a pretty interesting alternative. There are a couple other. So we mostly talked about core boot and Tiano Core. Some Microsoft devices like Surfaces, they had their own branch of Tiano Core. I think it was Project Moo, where they kind of stripped down some of the stuff out of EDK and put some of their own stuff in.
Yeah, there's some special Microsoft sauce up there if you go through their GitHub.
That in preparation for today's interview, I went ahead and let my Microsoft Surface suddenly go kaput, and no, not even update, just suddenly just like we don't need to start up anymore for you, and recovery was trash. All for you guys. I just want you guys to know that I purposely let a Windows machine tank for you.
We appreciate the sacrifice.
So we've mostly been talking about Windows and Linux, but like Apple devices are using
EFI.
their own variety of EFI these days. So
especially even all the Intel ones did.
Yeah. But they have their own fork of EFI.
That's Apple
as well.
Interesting. Of course they do.
Yeah.
We're starting to get close to the
we're gonna change it up a little bit.
Oh.
So just work with me, Alvaro. Just go with it. First of all, as always, we like to ask, we're gonna do this a little out of order, so just go with it. We want to ask our guests our typical question. Tell us what your favorite tool is, the thing that you can't live without.
I think the one that I really can't live without all the time, at least for now, is IDA. I'm using Binary Ninja more and more, but I spend most of my time in IDA. Literally, when I got on the call was prepping to get on the call for this, I closed 10 different IDA instances that I had running, looking at different UEFI modules that are interacting in different ways. Where it's like one was doing a locate protocol of this other thing. So primarily IDA. I also, I mentioned the DediProblem. I use that pretty frequently also, just because a lot of the time I am working with the physical device. So I'll grab that out and clip that on and mess with it. So those are probably my two most commonly used. It is kind of a love-hate relationship between those, but
it's x86, so it was always going to be that.
Yes.
Mickey.
Yeah, mine. Well, I have a few. Of course, DediProblem. I keep buying them.
You got to collect them all.
Yeah, I have a DediProblem. I love a DediProblem. I clip on everything. It's an SIC8. I clip on it. But definitely some of my tools my favorite that I use most of the time, Binary Ninja.
Yeah.
Because I don't have IDA. And it seems more a reasonable approach to reverse engineering. Then UEFI tool. I use UEFI tool a lot, but I use UEFI tool is a two-sided coin. So I use UEFI tool, the new engine and the old engine.
Okay.
Both of them. And my favorite hex editor, 010 editor.
010 editor.
Yeah, and something completely unrelated to reverse engineering. I use something called fences.
They're perimeter around your yard. Keep riffraff
It's
out.
a simple tool. It's a simple tool. Like I thought it was. It's a simple software that allows you to organize your icons in a Windows desktop in different squares.
So you have a icon on your
Stardock
desktop
Fences
problem.
5?
Yeah, that's the one. It's
I
have so many. I have so many icons on my desktop. I use Windows because most of my tools are Windows based. But
there's this thing called shortcuts and menus.
No, this actually looks nice.
No.
I put a link.
Okay.
This is organizing them in bunches. Like I have a fence square for just my remote desktop connections and one for my reverse engineering.
Fair enough.
It's great.
Yeah, I know. Most of us just have icons everywhere. And
I
am not in that. I just put things in folders. And then,
well, this is
I have a folder, and then the old folder, and the old folder inside that, and then it's a mess. So I like drag everything. Yeah. It's like I need to commit like both browser and desktop bankruptcy every once in a while.
Oh yeah.
No, in true ADHD, in true ADHD way, when you have like a pile of things that you know where something is at that pile.
Yes, and it's organized that way. Like you only know it from that pile in that location. But if someone moves that pile.
Here we go. So that's my point. So I was going to say, when I use my laptop and I switch to a docking station, when you switch displays, it reorganizes all the icons.
Oh, yeah.
Oh, nice.
So there you go.
The fences keeps it kind of in the same bunch.
I see.
So it keeps my ADHDing.
Yeah.
Keeps
and also the 010 looks nice too.
Okay.
Yeah. It's a cool, simple. Well, that and Notepad++ also, let's say.
Yeah, that was a classic.
Wait, what is it?
Notepad++.
Oh.
I mean, I used to use that a lot when I was mostly Windows.
Yes, it exists in my land, but I don't think I use it that much. Okay. This is the final question that we have, which actually is a multi-part question and is going to involve some amount of moving around.
Uh-oh.
Just giving you guys a heads up.
Okay.
So... both of you guys have done a lot of conference talks together. I would say you guys are kind of an infamous, consistent research pair couple, let's just say. How well do you think you guys would do on the Newlywed Show? Or the Newlywed Game? Any guesses? No? Yes? Pretty well?
I don't know.
Let's put it to the test.
Oh, you have questions.
Yes.
Questions.
So, Jesse, can you do me a favor and take your headphones off and kind of walk away and maybe come back in come back in 2 minutes. We'll let you know when you can come back. Okay.
He can't hear us.
Good. So I'll let him know when he can come back. So, Mickey, we're going to ask you a series of questions, and the whole idea is to see whether you two know each other as well as you think you might.
I didn't know this was going to happen, by the way.
I know he didn't either. I didn't either, but it's happening. Okay, so we're going to just ask you questions, and we're going to see how your answers compare to his.
Okay.
We're only going to do one round of this, so it's going to be really easy.
YOLO.
Where is your favorite place to write UEFI code?
Favorite place?
Yes.
As in,
not the butt.
No.
I'll put a link to that one.
I'd probably say where he is right now. Where Jesse is right now.
Okay. Great. Okay.
If he has the choice, he won't.
If he has a choice. Okay. Next question. Favorite property to write in BIOS.
Favorite what?
Property. So we talked a lot about properties. Do you have a favorite?
Maybe, the favorite area, I would say maybe a bootloader or secure boot.
Okay, writing down your answers so we can compare later on. Okay, if you were a port, what port would you be?
Oh, God.
You enjoying this, Alvaro?
Yeah.
Just a little.
Well, Jesse's reactions to...
Jesse just like, what's going on? Don't telegraph with your eyes.
I don't know.
There's only
It's just like-
256 answers here. I think.
yeah. There's not a lot of options to choose from.
I was like,
I'll just stick to the safe one. I'll just say port 80.
Okay, port 80. Assuming that's in hex. Okay,
Yeah.
going to the next one. When you need to go fast, what keyboard shortcut do you use?
Oh,
I've disarmed him.
that's a good question. I don't know what. I guess it depends on what OS he's currently using. If you want to go fast.
This is you. This is you.
Oh, this is me.
This is you. We're gonna find out.
Oh, it'll be like the Windows key.
Okay, Windows key. Okay. Let's bring him back. And everybody gestured for him to come back.
Yeah.
I think he's got it. He's coming back. Okay. Hey, did you have a good time?
I did.
Did you see
yes.
our faces?
I saw there was a little bit of laughing, but
Okay. We're gonna see how well you know Mickey. Okay. We have a series of carefully calibrated questions
oh no.
that are gonna suss out how compatible you two are. Is there BIOS compatibility? That's really what we're asking here. Okay. So, how do you think Mickey answered these questions? Okay. Where is your favorite place to write UEFI code?
Not in the butt.
Yes, not in the butt.
Like favorite place to write UEFI code?
Interpret that however you want.
I mean, I do have a hammock in my backyard, but I can't really see my laptop very well. So,
sorry, I should. Where's Mickey's favorite place to write UEFI code? Just want to make sure. Remember, this is how Mickey would answer.
This is how Mickey would answer. Okay.
No, but Mickey, you answered as if.
I answered for Jesse.
Yeah. So, Jesse? What is your favorite place to write UEFI code?
Yes.
I would probably still say my backyard.
I guess that's technically accurate. It is wherever Jesse is.
Well, it was supposed to be where you are right now.
Where you're,
okay, yeah.
Technically, it's a few feet that way.
Right, it is right that way.
By distance?
I do spend a lot of time in my basement here. I sometimes... So the reason I would say my backyard is because I spend so much time in my basement that's like I need to get out of the house and get.
You need some vitamin D.
I need some sunshine. So.
Yes.
Yeah.
We can't really always live up to the stereotype that we are basement dwellers.
I know. Yeah.
Okay. Next question. Favorite property to write? We've been talking about those a whole bunch.
Like favorite protocol or property?
Like region idea.
Region.
Mm-hmm.
Like some not region in the SPI. Like some concept. What's favorite topic?
I do well. Like what region to talk about or what region to rant about?
What
That's
feature?
A wrinkle on that.
Favorite.
I mean, like this secure boot bypasses, I think are fun, and just
okay.
Some of the.
Is that your final answer? Would you like to phone a friend? No, I'm just kidding.
I mean, so I think probably the remotely exploitable ones that we looked at were more fun because it was like stupid simple buffer overflows that you can turn into a fun bypass of all of the secure boot things. So
well,
probably
you're in luck because he did say secure boot. Okay. Congratulations, you guys are still in it to win it, whatever that is.
Okay. We're not heading for divorce yet.
No, we're not. No, you guys are on track. Okay. If Mickey was a port, what port would he be?
That was the face palm you saw.
Right, yeah. I would probably say port 80, like we talked about.
Oh my god! Oh my God. It's meant to be.
I know.
See, I was thinking, like, is it Ethernet, like RJ45, USB? I would have gotten it totally wrong.
So there's the architectural ports versus like the
yeah, we talked about
like
exactly.
ports,
exactly.
So. We did mention USB
for 43 port.
DCI.
Okay. When Mickey needs to go fast, what keyboard shortcut does he use?
Well, he does have the Stream Deck, so he could just press a button and it'll do like keystrokes for him. So
okay, is that your final answer?
Yes.
Well, we have to leave a little bit of mystery between you two because he said the Windows key.
That's fair. Yeah.
Don't joke.
Now, I do have a Stream Deck, which it sometimes it is my favorite when I work on debugging UEFI.
Yeah,
we just have macros.
I have a macro, so I have a macro for building EDK2, and then I have a macro for running a QEMU VM, and then I have a macro for killing QEMU because it gets stuck.
Excellent. All the secrets.
That's pretty good.
So, yeah, it's really handy to get one of those. If you ever need to do a repetitive macros for something, get yourself one of those.
Okay.
Yeah.
And before we wrap up, Jen, I did want to mention, and I think maybe Jesse, I'm going to be at TourCamp in a few weeks.
Cool. Yeah, I'll be at TourCamp.
Well,
sweet.
Maybe I'll see you there. And then if anyone listening is there, we did a meetup last time. We'll probably do something again.
Oh yeah. Yeah, I'm in Portland. I might be camping near the Dorkbot PDX people.
Oh, nice.
Of course.
Kind of that area in general. So
yeah, I don't think we'll have another episode before then, but so
cool.
Just let people know with our erratic
TourCamp
schedule.
is a great conference, but
yes,
I don't have my ferry reservation, so I need to like
set 2 weeks before.
Yeah, 2 weeks before I need to set my alarm for 7 a.m.
Yep.
Or write a script.
Be ready to like hit buy at 7 a.m.
Yeah. Anyway, just wanted to mention that.
Yeah, I would say like my Wisconsin hardware meetup is slowly getting better.
Oh, nice. Come in. Something.
Still looking for people. If not, just reach out to me at RobobotJen. Okay, are we closing out the show? Are we ready?
Yeah. So,
guys, go ahead.
Where can folks find you online if you want to be found?
Or a TourCamp.
Yeah, I'll be at
that'll be offline.
Come say hi.
That'll be offline.
I'll be at DEF CON in Vegas as well. So come say hi.
Still debating on that one.
Yeah, I have a Twitter account that's just my name, Jesse Michael, but I don't post anywhere near as much as Mickey does. So
I rant a lot.
I mostly just retweet interesting research and things that I see. So
cool.
Yeah.
But you can totally DM me there or say hi at any of the conferences you see me at. Or
awesome.
Yeah, and if anyone wants to reach me, they can ping Jesse.
Okay.
Your assistant?
I'm kidding. Yeah, I'm kidding. I have a Twitter. It's one word, hacking things, and that's basically what I use to get push notifications. If you want to DM me, DMs are open. Not a lot of people want to talk about firmware in UEFI, surprisingly.
Well, you'll find a few now.
You probably
we'll send them to you.
Okay.
Cool.
Since you offered that up. Okay. Alvaro, where can people find you if you want to be found?
AlvaroP.com and Alvaro Prieto on Twitter. I also don't post very much anymore, but I'll retweet occasional things.
Same thing on Twitter. I
don't post anywhere anymore, to be honest.
I feel like I don't either. Like I'm so angry at Elon Musk, but whatever.
I'm just tired.
Also tired. Hey, do any of you have show comments or whatever? You can find us still on Twitter at unnamed_show, which we probably don't even look at anymore.
Sometimes
so
we do.
Why bother? I guess, yeah.
I'll check sometimes.
I mean,
or you
whoever's listening, I challenge whoever is listening to start poking at that and start communicating.
Or you could write us on our comment form, which we'll never look at. So that'll go right into the void. But you could still find us on unnamedre.com or on Mastodon at unnamedshow_show. We have Patreons, so you could be part of that, especially if you like stickers. You can get some of those. We like podcast reviews. I'm really selling this.
I mean, people are already listeing to us, so I don't
know.
think we have to sell it.
Do you have a suggestion box if anyone has an idea?
We do. It's in the comment
It's
form.
a comment form.
But we don't look at it. Like I spent, like it was like one time I looked at something and somebody who I was working with was like, "Oh yeah, I know about your show." Didn't realize it was me the entire time because he listens on everything 2x fast. And he's like, "Oh yeah, I messaged you guys like a long time ago in the comment form." And I go and I look at him like, "Yep, you sure as hell did." And you only looked at it now, so whatevs.
So I guess maybe it's time for a new method.
I don't know. Just find us on Mass. We're not that hard to find.
Yeah.
I think that's the main thing. And if you like podcasts, you can find us on iTunes, Stitcher, Spotify, Google if that's still a thing. I don't know. Try it out. Oh, also YouTube.
Awesome.
Is that it? Are we done?
Yeah. Thank you. Thank you so much for joining us. This is a lot of fun.
Absolutely.
Thanks for having us.
So much good information.
Yeah, we needed another 3 hours, but we'll have to do part 2.
Or go to DEF CON.
Well, there's so many things I want to dive into, but
it's like I can get into a ridiculous depth of some of these things.
That wasn't deep.
It's like and rant about like other security issues.
I'll bring my portable recorder to
Thor
Camp in case anyone.
Are you going to do it on the boat? Are you going to get the boat again? And then
it depends who's in the ferry with me. I have done ferry recording before.
Well, you did ferry, and then you also were like in a rowboat interviewing people. That's how we did the crossover.
And, there's been a few.
Yeah.
But anyway, I'm gonna stop recording.
Yeah, stop recording.
Okay.
God, why are you drinking that green stuff?